Alrighty, we are in section 8.4, and 8.4 deals with using scientific notation. Now, scientific notation is a number. When it's written, it's in the form c times 10 to the nth power, where c is greater than or equal to 1 and less than 10. So if I was to write this as like an and statement for inequality, it would look something like this. We'd have 1, and it would be, it's going to be less than or equal to, say, c, but it will not be larger than 10. So basically, you have to find a number that's in between 1 and 9, whether that's a whole number or a decimal point. That is how we find scientific notation. So if we look at these examples we have here in the notes, I have in standard form, I have 2 million, and then I have 0.0005. So here's how we write standard notation. Standard notation for 2 million looks like 2 times 10 to the 6th power. Now you're wondering how we get that. Here's what we do. If you remember, even though it doesn't show it, there is a decimal point after the last 0 in 2 million. Okay? Usually doesn't show it, but unless there's decimal points that need to be used or numerical values that are less than 1. So what I would like you to do is to put in that decimal point, and then I want you to count the digits to where I would get to where I want my decimal point to be here, to make it at 2, because the value 2 is between 1 and 9. And so I count, I go 1, 2, 3, 4, 5, 6. And since I counted it 6 times, so it's 2 times 10 to the 6th power. That's where that 6 comes in. And any value in standard form that is larger than 1, it has a positive exponent to the 10th power. Now, if you look at 0.0005, that is a value that is less than 1. So it's going to be a really small number. That is written as 5 times 10 to the negative 4 power. So again, I need to get this value here in between 1 and 9. So I need my decimal points to be placed right there. Now I'm going to move my decimal point 1, 2, 3, 4. And because it's in standard form, the value is less than 1, it's going to give a negative exponent to it. Okay? So if you look at these examples here, I want to be able to write these numbers in scientific form. Okay? So if I look at A, I want to, first off, I need to get it into the C times 10 to the nth power. So we have to remember that C must be in between 1 and 9. Or 1 and 10, so it could be the 9 points. But anyway, so I want to put my decimal point right in between that 4 and 2. So my C, for example, A, will be the value of 4.259 times 10. And now I can go where my original decimal point is going to be. I'm going to go 1, 2, 3, 4, 5, 6, 7 to the 7th power. And I know that it is a positive exponent because 42,590,000 is greater than 1. B, on the other hand, is less than 1, so I know that that's going to have a negative exponent attached to it. So by looking at it, I need to determine where my C is going to be, so it means my decimal point is going to be in between my 5 and my 7. It can't be in between the 7 and 4 because that would make it 57.4, and that's larger than 10, so I can't do that. So for this one, it's going to be 5.74 times 10. Now it's a matter of counting the digits, so I'm going to go 1, 2, 3, 4, 5. And since I know that it's less than 1, it's going to have a negative exponent attached to 10. So it's going to be 5.74 times 10 to the negative fifth. Looking at 72, I know my decimal point's right here. I want to move it to here, so I'm going to go 7.2 times 10, and I moved it one time. So it's going to be to the first power. And you could also write this as 7.2 times 10. And that's you don't have to have the exponent of 1 because 10 to the first power is 10. Last example in this page, I need to use, I need the decimal point placed here, so it's going to be 1.06 times 10, and my original decimal point's here, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1.06 times 10 to the ninth. That is how it's written in scientific form. They're also going to ask you whether to write numbers back into standard form. So you're given scientific notation, write it in standard form. So here's what you do. Is I'm going to rewrite the value, so I'm going to go 2.0075, and now I have times 10 to the 6. So 6 power means that it's a value that's larger than 1. So that means I'm going to move my decimal point to the right-hand side of my digits, and I'm going to move it 6 times. So I'm going to go 1, 2, 3, 4, 5, 6. And you see these areas here where there's no values here, we're going to place zeros in there. And that's where the decimal point would lay. So this ends up equaling 2,0,0,7,5,0,0. So it'll be 2,007,500. That's how it's written in standard form. Let's look at B. So I got 1.685, and it's times 10 to the negative fourth. So that negative exponent tells me that it's going to be less than 1. So that means I'm going to move this decimal point to the left-hand side, and I'm going to move it 4 spaces. So it's going to be 1, 2, 3, 4. Put my decimal point there. I have 1, 2, 3 open spaces, so that's where I put zeros in front of them. So this ends up equaling 0.0001685. C, I have 3.03 times 10 to the fourth. Fourth power is a positive exponent. It's going to be greater, the value, standard form is going to be greater than 1. So I'm going to move it to the right-hand side, and I'm going to move it 4 times. 1, 2, 3, 4. I have 2 empty spaces, so I get to put zeros in there. So that ends up equaling 30,300. Last example on this page, I have 1.2034. It's times 10 to the negative 6. Negative 6 means it's a this is going to be a value that is less than 1, so it's going to be moved to the left-hand side of our number digits. So I'm going to move it six places to the left. So it's going to go 1, 2, 3, 4, 5, 6. Decimal point there. I have 0, 0, 0, 0, 0 to add in. So this ends up equaling 0 point, and I got 1, 2, 3, 4, 5 zeros in front. So 1, 2, 3, 4, 5, and then 1, 2, 0, 3, 4. It's a really small number. That's why they have scientific notation. It's the ability to easily write really, really big numbers and also really, really small numbers. Some of the things that they're going to ask you to do in your homework is to order numbers from least to greatest. Now, what I would suggest is get everything into standard form. So you're looking at it in the same form, and then you can kind of evaluate. You could also put everything in standard form if you'd so wish, and then evaluate. That's another way of doing it. So let's try both. Let's put them in standard form, and then let's put them in scientific notation, and I'm sure that they'll come out the same. So let's do standard form first. So 45,000, it's already in standard form. 6.7 times 10 to the third is in scientific notation, so I'm going to put this as 6.7, and it's times 10, so that's going to be 3 spaces to the right, so I'm going to go 1, 2, 3. So this ends up being 6,700. So that means that if I'm going to write this down from least to greatest, I'm going to go 6.7 times 10 to the third, comma, and then 12,438 is the second largest, and my largest is 45,000. If you wanted to put these in scientific notation, you could go, that 45,000 decimal point was right there, and then you can go 1, 2, 3, 4. So then I go 4.5 times 10 to the fourth power. And then for this one, it would be 1.2438. And then I'd go 1, 2, 3, 4. Oh, shoot. Let me erase that. It would be times 10 to the fourth power. Sorry about that. And then you can look at it in scientific notation and say, okay, my least greatest one would be this one because it's to the third power. And then you look at the two values that are in the fourth power, and 4.5 is larger than 1.2438. So either way, you still come up with the same result. This is the least to greatest for example A. For example B, I'm going to put them all into standard form. So I have 5 times 10 to the negative third. So I'm going to go 5, and then I'm going to move it 3 spaces to the left because it's going to be less than 1. So I'm going to go 1, 2, 3, decimal point. And so that leaves me with 0. So this is 0.005. And the least greatest one would happen to be this first one because it has the most zeros in front of the first value. It has 3 zeros ahead of it before I get the 5. So that means that my least greatest one in these examples would be 0.0005. The second one would be my 5 times 10 to the negative third because that has 2 zeros in front of the 5. So my second one would be 5 times 10 to the negative third. And then my largest one in this particular example would be 0.04065. Okay. Last examples that you're going to be given is they want you to evaluate expressions, and they want you to give answers in which they're in scientific notation. So I look at example A. I have 4.4 times 10 to the third times 5.5 times 10 to the negative seventh. So here's how you solve this one. First off, I want you to multiply 4.4 times 1.5. So I take 4.4 and times it by 1.5. I come up with 6.6. And this value is greater than 1 but less than 10, so I'm good there. So I go times 10, and then I see I'm 10 to the third power here, and I'm 10 to the negative seventh power here. So now we have to go back like what we learned in earlier sections, is we have to use the product powers property and add these exponents together, because we have the same base of 10. And so since we're multiplying the tens, we can add the exponents. So I have 3 and negative 7. So 3 plus a negative 7 gives me a negative 4. So 5.4 times 10 to the third times 1.5 times 10 to the negative 7th equals 6.6 times 10 to the negative 4th. Okay? Last example I have, this is a division problem. I have 5.4 times 10 to the negative 5th divided by 1.8 times 10 to the negative 2nd. So same thing as I did with the multiplication. I multiplied the two digits together. I'm going to do the same thing. So I'm going to divide these two together. So I'm going to say, what is 5.4 divided by 1.8? That happens to equal 3. So since I have 3 that's in between 1 and 10, so I can go 3 times 10, and then I can use the quotient power property rule and say, okay, I have the same base of 10, and so if I divide 10 together with exponents, I can subtract the exponents together. So I have a negative 5 minus a negative 2. And negative 5 minus a negative 2 equals a negative 3. So 5.4 times 10 to the negative 5th divided by 1.8 times 10 to the negative 2 equals 3 times 10 to the negative 3rd. And that is how we use scientific notation. Hope this helps. Till next time.